All right, thanks for having me, everyone. My name's Luke Kim. I'm the founder and CEO of Spice AI. We're a seed stage startup working on helping developers build AI-driven applications. Quick about me. Previously, I was at Microsoft, built an incubator in the CTO's office in Azure. Actually worked with David there, and built a number of open source projects, worked on a bunch of infrastructure as well. So this slide shouldn't be new to anyone in this room, but of course, what we know is, and what we've seen, market leaders leverage AI. And just one example of this is personalization. McKinsey actually found if you add personalization recommendations to your product, you would make 40% more revenue than if you did not. And then the change of if everyone did that would be about $1 trillion of additional value. And so we already know leaders like YouTube, Netflix, Amazon use recommendation models and have become leaders. And of course, this applies to many other areas of applying AI ML as well. And that could be anything from security to wallets to marketing and so forth. And what we're interested at Spice AI, at least initially, is how do you apply AI ML to Web3 data, decentralized data, digital assets, and so forth. So yes, this question, how do you apply it to Web3 and decentralized data? It's not as easy as you might think. Web3 and blockchain data is actually really painful. You've got to build and operate massive networks of blockchain nodes, which are quite painful to run sometimes. Obviously, build and operate big data and AI infrastructure. And you have to really understand some of the details about smart contracts and logs and events and things that are happening in the network to actually make sense of this data. Yeah, it's kind of painful. So what you find is if you want to go from these primitive data sets, blocks, transactions, logs, and this can also include other types of decentralized data like NFTs, for example, or IPFS, stored information, and you want to build it into something useful. So first, can we go to an enrichment stage and actually make sense of it, go from a transaction to a trade, and then eventually apply data science and AI ML to it to go to intelligent data sets. What you find is blockchain data and decentralized data is often open, but not that easy to actually use. So with that, we built Spice.xyz. It's a SQL-first platform for querying Web3 data, and it provides that data over high-performance Apache Array APIs specifically for data science and machine learning. And so we index a bunch of blockchains, and we produce that data and provide it to developers. Now, what's interesting about this is we have some interesting compute over data requirements. Some of the goals for us were to be the platform. So we didn't want to just run this for ourselves, but we wanted to build a platform that allows other people to run compute over data within the platform on Web3 data. And that could be index data, but could also just be general decentralized data that would be stored in IPFS. And of course, if you're doing that, you really want to be able to bring compute to the data. We run in a whole bunch of different data centers, including our own on-prem data center. And then you also want to bring compute to things like IPFS nodes where a large amount of data might be stored that is completely separate from where we've got deployments and so forth. And then, of course, we also wanted it to be open. So an open source runtime is really important. A local developer loop that developers understand is really important as well. So what we have is, this looks complicated at first, but is actually a cut down version of what we have. You can imagine that we have two data centers here. One is one of our data centers and an AWS. And what we can enable essentially is both SQL query into index data. So we have an indexer, and that will put it into our data systems, and also inferencing on ML models, which go into inferencing systems. But the cool thing is we can actually run our jobs, compute jobs, in Bacalhau containers that will produce outputs. And for example, one of the outputs that we might produce is an ML model. And we could run that in one of our data centers and then have that P2P sync back to the other data center and in a content addressable way. And then further, if we have our GPU cloud is in a different data center, we can then schedule that compute to go over to there, or for example, in the case where we do large-scale NFT processing, instead of pulling every NFT in the world to our data center, we can, in the future, hopefully, be able to run through the public Bacalhau network our compute job on NFTs that are pinned to an IPFS node somewhere else, and so we just bring the compute there. So this concept of bringing compute both to hardware, that might be specific GPUs and so forth, and to data, that might be specifically stored in some IPFS node or in our data center or so forth. So that's a really quick run through of what we do. This may or may not be a good idea, but the plan was to actually do live demos of all of this, which I haven't seen so many people attempt today, but let's give it a go. So a couple of things I wanted to show is, so this is a platform, and so we have, like I mentioned, a whole bunch of different data sets here that we have indexed. One of these here is a bunch of Uniswap data. And so if I was to log in to Spice, then I've got this demo app here. And like I said, one of the goals is to build a platform that you can both query data, but then apply large-scale training to produce models. And so here you can see we've got a basic SQL query, and I'm just pulling data from a Uniswap pool and click run. Should run pretty fast, and we have a whole bunch of blockchain data readily available. And so we put this type of data in train models. A basic model here that I just wanted to show is, and this is a caveat for research purposes only, you should not trade off this, but we're essentially predicting the next block price for a Uniswap pool here for this model. Now, the problem is, if you want to do this, it's really just an example, but if you want to do this, you, as mentioned by other people here, you often have to do some work on that data before you can start training on it. And that data might be NFTs stored somewhere else, it might be data stored somewhere else. So how do we actually run jobs on that? So what we have here is a very basic application that we would run in a essentially Bacalhau job. And so here, it's really, really simple. Just as an example, we're just going to do a little bit of manipulation to the data on some data that's coming in, which is blockchain data. And we're going to produce an output, and we're going to put that into the platform that we'll use for inferencing. Now, the local developer loop is really important to people. So what we wanted to show is that we can run all of this through Bacalhau locally, and then we can actually run it hosted in the cloud. So let's hope all of this works. I'm going to start an IPFS daemon here, and then I'm going to start Bacalhau here, and we have to use the dev stack here. So I'm going to copy and paste this. It's a little hard to do with. And then I have to copy and paste one more line. So that's set up IPFS and Bacalhau, so that's running. And so now I can actually just start my local runner, which is just going to run that main Pi function. So I run that. And that's going to start a Bacalhau job, which is going to query Spice, take index data, do a little bit of manipulation to it, and output it back into IPFS and have that content addressable. Now, this has previously taken anything from 10 seconds to 45 seconds. we would probably want to talk to the Bacalhau team as to why that is, because we are not 100% sure. So we'll see if that keeps running, and in the meantime, I'll swap over to here. So essentially what we have is we have this repo here, it's the same repo here, and we have two folders. So in this folder here is the, is that main function that we just ran, and actually let me swap back to, no, it's still going, okay. So that's the main function that just ran, and so if I come into Spice here, we have essentially an application container. And so I can come in here and I can connect my application to GitHub. Okay, cool. So now I've connected my application to my GitHub repo. And so if I come across to the hub here, you can see the application's connected and I've got my code files here. And so again, what we wanted to do was take data as it comes in, manipulate a little bit, and then use it for inferencing. So what we can do is actually come back to our application here, and we can set up a data set in a declarative way. So here in the .spice datasets directory, I've basically created very, very simply a table, and it's just going to store a timestamp and a Y value. And then I expose it using this view here. And so if I come back here, then I see that by connecting my repo, it's detected that there's a data set there, and then I can go ahead and deploy that data set. And what that's going to do is create that container for that data in Spice. Then I want to take this main function, again, that I applied and ran locally on my dev loop, and actually run that in a serverless way hosted within the system. And we've kept it super simple here. It's a basic manifest, and we simply can say we want to output to this data set that we had created in the previous step, this data set here. And we want it to trigger when we get new Ethereum data, essentially. So if I come back to here, I can now go to functions, and it's detected that function. And if I click deploy, it essentially bundles up all of that data that is in this folder, including the main function, and sends it into Spice, and then creates a Bacalhau job in the background, and deploys it. And then when new Ethereum data comes for every block, and so you can see the triggered block here, it will run that in Bacalhau as a job and output its data to IPFS, local IPFS in this case, and be content addressable. And so if you see this, these functions have been running now, and you can see that it does very, very basic manipulation, but to create that TS and Y value here. And so essentially what we've been able to do within the platform is take data as it comes, streaming data as it comes in, apply a Bacalhau job to it, and that was defined declaratively in a customer's repo that they control, and then take those outputs, put it into a private IPFS cluster, which then is available anywhere in our network. So when we run this in our Azure data center, that output can then be available in our on-prem data center, or where we have GPUs and so forth. And we can chain these jobs together so that you may go, if a Web3 data comes in and you say, hey, there's a new NFT minted, I can then process that, go run a job next to the IPFS node where the NFT is actually stored, do processing on that without having to actually copy that NFT back to my data center just to do processing on that. So it becomes very powerful being able to actually distribute this compute around to both, like I mentioned before, hardware and to the data. And so that allows us to produce models, and so we have some models within the system that we've trained, but the whole point is to enable others to actually train their own models and do their own compute jobs themselves on decentralized data. So that is the quick demo, Hopefully you enjoyed that. And so let me come back to the deck here. And so what we have here essentially is a way that you can define in YAML declaratively a new data set that's available in Spice that you can go query. And in fact, I didn't show that, but let me show that real fast. So what we actually produced there, was a new data set, which I can actually go in and query. And it's just in my namespace here. That Uniswap ETH data, and then that table has all of the data that was produced. So, and then I can take that data and I can run it in Bacalhau jobs where the hardware is or where the data is. So we have custom data sets, and then we have Spice functions, which are these compute jobs that run through Bacalhau private clusters, and then Spice models. And we actually have, we've created a model store completely built off IPFS for content addressable models. So the functions can output a new model, it's content addressable, and then we can use that model anywhere in the network. So what might you want to do with this? We have a bunch of different use cases, anything from NFTs to security to trading to accounting. One interesting one is this Yukoa here. And so they are doing IP infringement detection for NFTs. And their particular problem is they have to take every NFT that's ever been minted anywhere in the world ever. And they basically look to see if any NFT, when was the first mint, and if any NFT even looks similar to another one. So people will take an NFT and they'll flip it around, or they'll add a dot to it to make it just slightly different. And so they put all these NFTs into similarity processing engines like ResNet and figure out if they're the same or not. The problem is, if you have to take every NFT in the world back to your compute to figure out if they're similar or not, that's a lot of data transfer on a growing set of media, and very hard to do. But with Spice together and distributed jobs, you can go run, take a query across all the NFTs, which is actually hard to do in itself, but you can do in Spice, and then run your job next to the actual data where the NFTs are stored. So in summary, having this ability to do massive distributed and decentralized compute is really a requirement for training models on large amounts of Web3 data that's only growing. It's really just impossible to do that centralized, especially when you start talking about the exabytes of data that's stored in IPFS and Filecoin in these other systems. And so Bacalhau enables us to run the compute in where the hardware is or where the data is, and that could be different clouds, it could be public and private IPFS data sets and so forth. And the other cool thing is that when paired with IPFS, it enables this peer-to-peer sync of things like models. So we can train a model in one place and then use that in a different place with a nice peer-to-peer just-in-time sync. And all of these things, custom data sets, functions, models, our internal model store are all powered by Bacalhau and are in preview now for our design partners. So with that, if you are interested in the platform, you can check it out here, some docs here. We do have a waitlist right now, and so if you're interested in taking a look, just email me your GitHub username, and I'll take you off the waitlist. That, thank you. Any questions?